All right, so back to name that polygon. Cross some lines here. A polygon with at least 2 pairs of parallel sides. Any thoughts on that one yet?
Parallelogram?
Parallelogram, so I could have that side there, and then hope that's parallel to it, and then we can have that side there, and hope that's parallel to it. So parallelogram is definitely one option. Are there others?
Are parallelograms and rhombuses different, or are they basically the same thing?
Good question. So let me get my pen. Switch to black. Parallelogram versus a rhombus. Rhombus. So does this figure right here look like a rhombus that I just drew? Yes, I got a maybe. Why is it a rhombus? That would make it 2 pairs of parallel sides, making a parallelogram.
It has 2 pairs of congruent angles.
That makes it a parallelogram.
Man. All those sides are the same length?
That would make it a rhombus if it has 2 pairs of parallel sides and it has all sides the same length. So, but I didn't draw that with this in mind. So my thought is these sides right here are a little smaller than these sides right here. So if it's a parallelogram, opposite pairs of sides will be congruent. If it's a parallelogram. So this is not a rhombus.
A rhombus is all sides same.
Yes, rhombus is all sides the same length.
But a parallelogram could technically be a parallelogram with all sides the same length. Yes,
so a rhombus is a kind of parallelogram.
Okay.
Yes.
Okay, that makes sense.
Yeah, a rhombus is a kind of parallelogram.
So this question could be.
It could be a rhombus. It could be a parallelogram. Yeah. Anything else?
I wrote a trapezoid, but I don't think
A trapezoid is at least 1 pair of parallel sides.
A hexagon.
A hexagon? Yeah. Almost, not any hexagon.
Well, like an equilateral,
A regular hexagon. Yeah. So a regular hexagon would work here. Regular hexagon, is that right? Yeah. That would work.
like a square or a rectangle?
A square would work, a rectangle would work. Okay, so good question, good thought. Let's go back here. I got parallelogram. Now a rhombus is a kind of parallelogram, right? Is a rectangle a kind of parallelogram? Turns out, yeah. So by saying parallelogram, we're including rhombuses, we're including rectangles, and then if you make a rhombus equiangular, or if you make a rectangle equilateral, you get a square, right? So like if we're trying to pick the best name for something in this situation, a parallelogram would be the best name, not for what this says, because that says polygon. By saying parallelogram, we're restricting ourselves to only 4 sides, but it doesn't say it could have, more sides. So a regular hexagon would work.
Or like an n-gon of any sort, a regular n-gon.
Okay, let's test that out. Any regular n-gon. So I'm gonna.
Well, any even.
Oh, an even n-gon. Oh my gosh, that's such a great idea. All right, so I'm gonna check out my favorite program, GeoGebra here, just because this is a good opportunity. Because it has a button under More to make, if you point to them, it tells you what it is. It makes regular polygons. So I click on that, I point, that's the starting line segment, and then it says, well, how many vertices do you want? Okay, I could say 4, I could say 5. So earlier you said 6. So here's a regular hexagon. Oops, I meant to drag the screen. Let's make a regular pentagon. There's my regular pentagon. Let's see, I have to switch here. Okay, so yeah, here, opposite side, it has at least 2 pairs of parallel sides, right? This one actually has how many pairs of parallel sides?
3.
1, 2, 3 pairs. This does it have any pairs of parallel sides? Doesn't. So 5, 6, what would be next? A 7-gon, and I could make a 7-gon. We'll make a little one down here. Okay. 7-gon, is there anything parallel to LM? If we look across, there isn't anything. If we grab, say, side, oops, escape. I don't want to do points. If we grab that side right there and look across, there's nothing parallel to it. Yeah, so it can't be an odd n-gon. It's going to be an even n-gon. Okay, so that works. We're making progress. So regular hexagon. We're going to change that to be a regular even n-gon.
So then with that, could you potentially just get rid of the entire parallelogram idea?
So,
or
okay, so check
are we
this out.
separating those?
Is a parallelogram a regular even n-gon?
No. No, because it's not equiangular.
Yeah, it's not equiangular, and so this parallelogram right here is neither equiangular nor equilateral. So it fits my description for a four-sided polygon with at least two pair of parallel sides. However, so it turns out this captures a lot of them, but it's a little too restrictive.
Okay.
Yeah.
But like the square would fall under that, but not the rest of the square.
Yeah, so a square would fall under this regular even n-gon.
Okay. Correct.
But a rhombus wouldn't and a rectangle wouldn't. But they both fit, part of that description.
Yeah. Okay.
Okay. All right, so I'm going to throw another twist in this. So I'm going to trace out a new figure on top of my, this sucker right here, this parallelogram. So let's suppose we keep that much of this side, but then we just cut a little chunk off right there. We'll keep that chunk right there, and let's keep this part right there, and then we're just going to cut over that way, and then we're going to come over here. Okay. So this new red figure, my belief is that this side right here, arrow, is parallel to that side right there, and this side right here is parallel to that side right there, right? But these guys have nothing in common. They're neither parallel nor equal, congruent. Does that fit? Is that a polygon with at least two pairs of parallel sides? Yeah. So can we give this description a good name? If we can make up all kinds of things that work? Answer is no, we can't come up with a name for it. But we found some named polygons that work. Parallelogram, a rhombus, a rectangle, a square, any regular even n-gon will work. And then there's all kinds of other crazy shapes that will work.
So is that a hexagon? Just not a regular hexagon?
That is an irregular hexagon, yeah, because it has 6 sides. And I could have thrown in more sides. Like I could have given it like a little divot over here instead and gotten rid of that. So now I have a 7-gon, which is called a heptagon. And, right, so just double check here. I have 1, 2, 3, 4, 5, 6, 7 sides. So this is what's called the heptagon. It happens to fit this description because it is a polygon. It has at least 2 pairs of parallel sides. It's definitely not regular, right? Is it concave or convex?
Concave.
It is concave because it caves in on itself. Yeah. So I just made just a concave hexagon. So there's a gazillion different shapes we could draw that fit this description. So it's not specific enough to give it a special name, that description. And that's okay.
Are we going to go over specifics of concave and convex? Like, I get it, but the homework question.
Okay, we can take a look at the homework question in a minute. Make a note. That is in section 3. Homework concave. All right, we'll look that up in a minute. Let's take a look at another one of these. So there is no best name for that one. And the only way we can figure this out is just kind of by playing around with the properties we've been looking at. A quadrilateral with congruent diagonals. Okay, so it's 4-sided, got to have congruent diagonals. Let's see, so earlier I drew a parallelogram. Let's see, I want my line tool, there it is. trying to make those two parallel. And maybe that one. But I can just copy that and it will be. There we go. Parallel. Will this have congruent diagonals? Will. All right, I made an error there. Color problem. Line tool, red. So here's one diagonal there. Here's the other diagonal here. What can you tell me about those two? They're not congruent. Okay, so what can I do to make these congruent? Make the sides equal, maybe. So one problem I think is that this angle is narrow. Oops, that's on a pen. This angle's narrow, that angle's wider.
Make the angles congruent diagonal.
They mean the same length. Congruent would be, means the same measure. Yeah. So what was that, Ashley?
Make the angles more than likely the same.
Try to get them to be the same angle. Yeah, so we would make this angle wider, that angle narrower. And I think what's going to happen when we do that, make some duplicate sides here. Let's see, switch tools. Copy, so here. And then maybe right there. Oops, wrong button. Might this one have congruent diagonals? So one diagonal, oops, one. Green, sure. There's one, ooh, that's a pen. All right. Yeah, once the angles get to match, in this case, if they match, they're going to be rectangles. Then I'm going to get congruent diagonals. So draw a rectangle on a piece of paper. Rulers here if you need one. And see if you can confirm that. See if I can get that to happen in GeoGebra. Let's see, can I clear the screen? Nope. Don't save. Okay, so let's see. I want to make a polygon. And let's see, what are we supposed to start with here? Quadrilateral?
Yes.
Okay. I'm just going to build a quadrilateral. So there's a quadrilateral. And then I can go and throw some line segments in here and here. And GeoGebra has a tool to measure stuff. So I can say, hey, how long are you? And how long are you? Blow this up. Let's see, can I just settings maybe? I haven't used GeoGebra in a while. It's changed a little bit. X min, X max maybe. 1 to 1. It's not. Oh,
I have a question that kind of goes back to the first one that we did on here.
Mm-hmm.
So you drew the heptagon.
Yeah.
Did it have 2 pairs of parallel sides?
We're number 4. Yeah.
Since it was.
So I drew it on top of my parallelogram. So this side right here, let's use a highlighter. This side right here is parallel to that one, so there's 1 pair. And then this side right here is meant to be parallel to that one.
Okay, so it could potentially.
So the bottom line is you can have any kind of shape, concave or convex, totally irregular, and still meet this description. So what that tells us is that this description isn't specific enough to name a special polygon, because there's so many different ones we can draw. So we can't name that polygon. It doesn't have a special name. But we're leaning toward this polygon, which our new description is quadrilateral with congruent diagonals. That looks like it's probably what? Probably a rectangle, right? So what I can do is, since I told GeoGebra to measure these, I can start moving these points around, trying to make this happen. So 6, ooh, oh, interesting. It looks like they match, but that's not a rectangle, is it?
Could you try pulling them farther apart too?
Yeah, totally. So I'm gonna get more decimal places to see, because it's just rounding to 6.3. So I think that's under settings. Big, yeah, 1 decimal place. Let's go 5 decimal places. Okay, so they don't match. Zoom in a little more. So if I try to get them to match, oops, make that bigger. This is a tough one. Oh, getting closer. Yeah. Ooh, this is harder than I thought. What's it starting to look like? Starting to look like a rectangle, yeah. So if I could also tell GeoGebra to measure angles. And the order that you pick the points to measure the angles, it matters. Because if you do one way, you get the interior angle. If you do the points in the other order, oh, I lied. They changed it. Let's see. Did I just switch over directions? Oh, interesting. Doesn't seem to matter the order anymore. What if I want the outside angle? Okay, we'll work on that later. Yeah, so my angles, so again, I'm close here, and those are getting closer to 90. So it looks like we have some evidence that it's probably a rectangle. Yeah. That would include a square, and, ooh, it would include a square. Oh, what about a rhombus? Oh my gosh. Does a rhombus have congruent diagonals? Only if it's a square?
I think so.
So you can draw a rhombus. So let me see, if I want to draw a rhombus, what would I do here? Yeah, so sometimes deciding how to use the tools to make something can be pretty tricky. I need 2 pairs of parallel lines, and I need equal lengths. So if I start with a line, and then from that line, I make a circle, and then I pick some other line, like this one right here. Then what? I need another circle with the same radius. Okay, so these 2 circles are congruent because this is the radius in between those 2 points right there. I just need a line parallel to that one through here. There's a parallel line button right there. How does it work? Select a point and a parallel line. Okay, boom, boom. And then I need another line parallel to this one. So point, line. So this is a rhombus through here, right? But can you see this diagonal right here is way bigger than that diagonal right there? Yeah, and the only way, just like before, we're going to have to push these 2 points closer together, which will force the angles to all turn into 90s. Yeah, so it looks like we're looking at a rectangle. A square is a kind of rectangle, though. Yeah, so it looks like rectangle is the answer there. All right, where's my notes? There they are. Rectangle.
Is the plural of rhombuses, is it rhombuses or is it rhombi?
Ooh.
Like octopi or octopus?
Yeah, rhombuses, rhombi. I'm leaning toward rhombuses. But
Rhombi just sounds fun.
let's ask Google. So rhombus plural. Rhombi. Oh, rhombuses. Okay, cool. All right, you get choices. It's either rhombi or rhombuses. I love Wikipedia. All right. Next, A quadrilateral with two pairs of congruent angles. Quadrilateral with two pairs of congruent angles. So play around on a piece of paper. See what you can come up with. Two pairs of congruent angles. Quadrilateral. Can't be any quadrilateral. Have to get congruent angles. Oops. Two pairs of congruent angles. Oh, that's not what I wanted to do. Copy this one. Paste it. I make a parallelogram. I have, it looks like this angle is congruent to that one, and this one is going to be congruent to that one. Let's see. Ooh, another idea. Anyone else got a different idea besides parallelogram or rhombus?
Yeah.
What'd you get?
Trapezoid.
A trapezoid. Any trapezoid?
No.
A special trapezoid.
Yeah.
Okay, tell me about your special trapezoid.
It's nice and pretty like this.
Oh, yes. Okay, so let me see if I can.
Is that the isosceles?
Isosceles trapezoid. Yeah, an isosceles trapezoid. So let me see if I can draw one of those. Draw you in red. So I need a pair of parallel lines, and then we want following to be true. The length of this line should match that one, and this should be parallel to that. The top and the bottom should be parallel. And this will give us an isosceles trapezoid. So isosceles trapezoid. Yeah, so it looks like we have a couple of options, but any old trapezoid won't work. For example, if black, if this were my trapezoid, if this line is parallel to that one, that would be a trapezoid, but I have 4 different angles here. Any other ideas? And these are not trivial, by the way. So if you're looking at like, how did you come up with that answer? Sometimes when I look at one of these descriptions, it's like a day later, I come up with a new idea that I missed before. Right? So these are not trivial. You really got to think hard about them.
Would a square technically have one pair of congruent angles because like all the angles are the same, or would it still count as 2?
So here, I think we have some wiggle room.
Okay. Because
it doesn't say 2 pairs of, how would we word that? 2 different pairs of congruent angles, I guess
So
would be the way to word that. So here, both of these have 2 different
or
pairs
like
of
2
congruent
different
angles.
sized.
Yeah, so we've got this angle matches that one, and this one matches that one, and they're 2 different sizes. A square, they're all the same size, but I think it still fits.
Okay.
Yeah. Because it's not specific enough. Yeah, so we have a couple of good names for this one right here. We weren't able to come up with one name, we got 2 names. And I can't think of any other shapes at the moment. That doesn't mean there's not some other ones that don't exist if we're a little creative somehow. Trying to be creative here. Okay, what's up?
For number 1.
Yep.
So that couldn't be a square because it's not. Is it saying exactly 2 right angles?
Exactly 2 right angles. So a square would have 4 right angles, right? So that doesn't work there.
Okay.
Yeah. So we came up with for number 1, we came up with a couple ideas the other day. Squeeze this slide back here. So number 1, if we made a trapezoid where this was a right angle and that was a right angle, that would be one possibility.
Okay.
But then we had another idea where here's one of the right angles right there, and then I make the other right angle kind of twisted from that. Like if I make the other right angle twisted like that, and I extend some sides here, then I have another quadrilateral because it has 1, 2, 3, 4 sides. It's got only exactly two right angles. These are just other angles. Who knows what they are? So on that one, we figured there's no special polygon that fits that description because we were able to come up with multiple options for it.
Thank you.
Yeah, that was a tricky one. This was one of those where the first time I did this, I didn't think about that one until like a couple of days later. It hit me in a vision. You know, it's the weird thing about our brains. It's like, you know, when you're trying to remember a name and it just won't come to you at the moment, and then it just randomly pops into your head.
You should have a regular trapezoid.
Ooh, what would a regular trapezoid be? And all the same angles, which would force it to be a square. Yeah, you're right. Yeah. See how you could get fun with the naming of these things and see what you end up with? Okay, so where are we? Okay, a polygon with 1 pair of parallel sides and 2 right angles. Okay. Polygon.
I know what you just drew up there with the trapezoid.
Let's see, a polygon with 1 pair of parallel sides and 2 right angles. Yeah, that would fit it, wouldn't it? So 1 pair of parallel sides, 2 right angles. So there's one possibility. Now it said polygon though, which it doesn't have to be a quadrilateral. It could have more sides. Okay, so what other options are there? 1 pair of parallel sides and 2 right angles. Could it be a hexagon? Could it be a pentagon? Yeah, so play around, draw some pictures, see what you can come up with. I could do a quadrilateral based on that first one. I could do a pentagon based on that. I could do a hexagon based on that. And I could just keep doing that all day long. Are there any other options? So 1 pair of parallel sides and 2 right angles. There are other options. Let's see what I want to do. I want to draw. There's one side. Let's go parallel to that. Bless you. Bless you again. Okay, so we're parallel. Let's make it wider. So there's 1 pair of parallel sides. And then from there, I want a right angle. Maybe another right angle over here.
Can you make like a concave right angle? Is that possible?
Yeah, totally. Oh, okay. So good question.
Or would that make it inside the?
Yeah, okay, so yeah, where does the angle go? So let me see if I can draw that. Different screen. Let me finish this one here first. So I could then maybe come down here, and this one could come there like that. Yeah, so this is what a sides do I have? 1, 2, 3, 4, 5, 6. Okay, so I can do a hexagon, and here I have one right angle there and one right angle there. Yeah, so it looks like there's lots of different configurations that fit this description. I'm not seeing a pattern to these yet. You guys?
Can you go like any number? Can it just be any end going over?
It could be any, yeah, any n-gon. So I'm thinking there is no name for this polygon. Because there's tons of different things we can draw that are all different in their own way. Let me get back to Tiffany's question. So you wanted me in, let's see, a concave. Let's see. So we want to cave in. There's my right angle, and then make some other sides. So when we measure angles, the angles of a polygon, we usually talk about the angles on the inside. So if this is 90 degrees out there, then 360 minus 90 would be, this angle right here would be 270. So if it's concave with a right angle, that means its interior angle would be 270.
But then it doesn't count when you're 90-degree angles, and you can have two other 90-degree angles.
Say that again?
But then it doesn't count as
Yeah,
when you're 90-degree.
It doesn't count as a 90-degree angle,
So you
correct. Yeah. So that doesn't count as a 90-degree angle because it's the 90 degrees is on the outside of the figure, not on the inside of the figure.
Okay.
Yeah. So they're referring to interior angles usually when they talk about properties of a polygon. Okay, so we don't have a name for that one. Okay, let's move on. I'll make a note of that. No good name. All right, let's see, where are we? Moving along. One more, a quadrilateral with two pairs of congruent sides. Ooh, this is a good one. Start drawing some pictures if you haven't already. Let me know if you have a name for it. Square.
Rectangle.
Rectangle. Yeah, I think a square works here. So let's see if we can make a good square. Let's see, rectangles. So usually on computers that draw geometric shapes, if you hold down Shift while you're drawing, it forces it to be proportional. Sides are the same length. So here the rectangle tool, holding Shift, turns it into the square tool. Similarly, if I brought up the ellipse tool, which I can make all kinds of crazy shapes, once I hold down Shift, what's going to happen?
Circle.
It's going to turn into the circle tool. Yeah. It's kind of cool. Okay. So in most drawing programs, that's the case. Let's trash that one. Okay, so we got a rectangle, a square. Oops, wrong button. A rectangle. So here I have a pair of congruent sides. Here I have another pair of congruent sides. It didn't say it had to have all four sides congruent, right? But it says two pairs of congruent sides. So what are there other options?
A rhombus.
A rhombus would work too, yep. Anything else?
Parallelogram.
Yeah, it turns out a parallelogram will work. Magic pen. So we've got square, oops, wrong tool, square, rectangle, a rhombus, what else? Parallelogram. Parallelogram, something like that.
You
Anything
can't
else?
have a parallelogram with sides that are like without having two congruent sides.
because the parallel lines cut each other, you're always going to have two pairs of congruent sides.
Okay.
Yeah. Yeah. So what's the best name here of those four?
Parallelogram.
Yeah, because a rhombus is a parallelogram, so is a square, and so is a rectangle. So far, the best name we have is that one right there. But are there any other shapes that fit this? I believe there are. Besides that, I believe there's a shape that's not a parallelogram that fits this description.
It's a quadrilateral.
That's a quadrilateral. Now, there is I think, I'm picturing it in my head. I'm imagining a windy day and a whole lot of string. A kite. Think about what a kite looks like. So a kite often oops, that's not a pen. Again, in red perhaps. Yeah, so a kite looks kind of like this, right? And usually this side and this side match, and this side and that side match. Two pairs, congruent sides. Yeah. So a kite works here also. And that is a mathematical figure. Yeah, so it looks like it's a kite or a parallelogram. So this is one of those that a couple of years ago I was doing this activity and someone in class the next day said, we were wrong about parallelograms. So I missed it, but somebody else got it. Okay, so the next step was for you guys to come up with a description, a statement. And then we have to come up with a name for it, if possible. So, did anyone already try that extension? Okay, so we'll leave that for homework. So the extension on this one was to come up with a description, kind of like these right here, and then everybody else next class is going to have to try and name it. So we'll play name that polygon again next class with whatever you guys come up with. All right, so next part, we are going to jump on to the next activity. So part of section 3 is not only types of polygons, but it's the symmetries those polygons have. So we're going to play around with the idea of symmetry. And we want activity 4. And this one requires scissors, paper, and rulers to do. So here's the gist of it. You're going to, first step is to make two lines. One line is going to be called AB. The other line is going to be called BC. They meet at point B. The two lines have to meet at a 60-degree angle. Okay, so there's a couple ways you can come up with a 60-degree angle. I have these mini protractors up here that you could use to measure a 60-degree angle. But where else did we see a 60-degree angle recently in our playing together? The paper circle.
Yeah.
Yeah, so you could use the paper circle to line up a 60-degree angle because we made an equilateral triangle out of the paper circle. So you get a couple tools to draw that 60-degree angle. Following that, so then once you draw those two lines meeting a 60-degree angle, you're going to just around the point B, you're going to draw some crazy irregular polygon. As many sides as you want. Don't go too nuts with the number of sides because then the next part gets painful. Okay. So then what you're going to do is you're going to fold the piece of paper in half along the line AB. And what you'll see is, if you look at it one side, you'll see one half of the polygon. And if you flip the paper over, you'll see the other side. So what you're going to do is, looking at one side, you're just going to cut out that polygon while the paper's folded. Then you're going to flip the paper over, and you're going to cut any remaining lines that are on the other side and see what you get. Okay? Go for it. Do you want colored paper, anybody?
Sure.
Okay, let me grab some colored papers.
As the spice
Oh.
into our life.
I did forget the colored paper. I'll be right back.
I was wide awake when I got here and suddenly.
Okay, I'm gonna see if I can pull this off in front of the camera. So here's some colors. Come grab some color. There's rulers up here. There's scissors up here. You'll definitely need scissors. All right, and I am going to try to do this for the camera.
How big do you want it to be? Matter?
Doesn't matter. Yeah, don't make it too small because it'll be too hard to cut out. So you probably want to use most of the paper. All right, so I'm going to talk to myself up here. I'm talking to the future studio audience, so feel free to ignore me for a few minutes, those of you in the room. That doesn't matter how long the lines are. I would make them as long as possible because you're going to be folding the piece of paper on each line. And you have to label one AB and the other BC, where B is where they meet. And they have to meet at a 60-degree angle. That's also important. Okay, camera, can I do this? Use the keyboard, switch to camera. Come on, camera button. Hello. All right, let's see. Just look. Okay, hello. Yes, I did nothing else. All right. See, Ashley, may I borrow your triangle, your folded circle thingy, so I can get a quick angle? Thank you. All right, so folded circle here, 60-degree angle. There. All right, Polygon time.
For some reason, I feel like it uses this flavor.
Okay, I can help you with that.
Yeah, I think I screwed up.
No, that looks good. That looks like a 60-degree angle. Yeah, so if I put that in the center and line up those two flat parts. what just happened there? Hello? Camera. Is this a new recording? What was going on in between? I have no idea. So we'll just get back to it. All right, so Polygon.
What happened? Oh,
Ooh.
it ended.
Yeah, and it could be concave, it could be convex, doesn't matter. All right, so here is mine right there. So now I have to fold along AB. The best of my ability.
You made a human.
Oh, cool, look at that. Nice. All right, so fold it there. So cut along one side. While the paper is folded in half.
We don't cut line BC.
Correct, you do not. You're just cutting along the edge of your polygon. Yeah, so once you cut out one side, flip it over and cut off any other side. So here, I have to slice there, there, and there. And then open it up. What'd you get? I got a little, I don't know what mine is. I got that fishy thing maybe. Okay. So the figure, everybody made a polygon with a line of symmetry. So we took the original irregular polygon. By folding and cutting, we now have a polygon with a line of symmetry. Okay, so that one side is a mirror image of the other side. Tiffany a minute, and then we'll flip the page, move on to the next part.
Did we ignore some of our?
Yeah, because you cut out one side and then the other. Yeah. Yeah. So lots of different things can happen, and everyone's going to be a little bit different. So is yours symmetric about that folded line? Yeah. Okay. So we have now a line of symmetry. So a polygon with one line of symmetry. All right. So let's check out the next page here. Where'd it go? Lost it. There you are. Okay. So the next page says, now fold along line BC. Fold along the other line. And repeat the same process.
The human was so cool.
No. Yeah, there's evolutions in this right here. So cut anything that's sticking out. So let's see, how do I get back to there, not there. Okay. That's my other one.
Wait, you said cut everything that's sticking out.
There we go. Yeah. So here, when I fold it in half, I get some pieces that are sticking over the edge. So I'm just going to cut those off. So let me see yours. Yeah, so any flap that's hanging that's not doubled up, you're going to cut along that. Get rid of it. Yeah.
On both sides.
Yeah, so do one side first. Flip it over, do the other side. So I'm going to have to cut right here, here, there. And then we'll cut a tiny piece right there. Flip it. Repeat.
I know it looks like Yoda's head.
Yoda's head. Okay, so then I flip it over. Okay, so open it up. And what do you have now? Figure that's symmetric about the other line. So I should label mine. That's B. A was over here somewhere, and C was over there somewhere. So then what I want you to do is once you open it up and see that it's now symmetrical around line BC, fold it along AB again. What do you notice? It's no longer symmetric. Fix it. So some more cutting. So I switched back from line BC fold to line AB fold. Gotta get the shadow right to make that cut. Get that side, flip it. Almost. All right, open it up. Double check, fold it along BC again. And you'll probably have to make one more round of cuts.
Is it possible that we can?
It's possible. Did I make a mistake somewhere? Or my figure was just complicated, maybe.
So do we need to keep cutting until it's congruent on both?
Yep.
lines? Or asymmetrical on?
Yeah, symmetrical on both lines. Good. And mine was trouble. Interesting. It's not working out the way it did earlier. Did I miss a step? I'm going to double check the directions. Did anyone get theirs to go right away on the next set of folds to whip into shape? So let's see, did I miss the direction? Let's double check. All right, so first time we got our one line of symmetry. And we fold along BC, cut away anywhere there's only one layer of paper, turn it over, cut off any other one-layered sections, open the paper, how many lines of symmetry, continue folding over AB and BC, cutting off undoubled parts. This should require one more fold. That's what I thought. Huh, what did I do wrong? Draw an irregular polygon. So the first time I did it, I'll show you my sequence of events. I made my lines in my polygon, and then I folded the paper in half. There's both sides, and cut one side and then the other. So I have this line of symmetry. So this is line AB right there. So then I folded it again, and cut. So then I got symmetry along the other line. So then I folded back along AB, and I got this figure right here, which is now symmetric along both lines. Now the cool thing you should notice about that, did anybody find another line of symmetry in their figure? You're still cutting, Ashley?
Yeah.
Okay, so yeah, you and me did something weird. You're still cutting too?
Yeah.
Okay, so I got to figure out
I'm gonna
what.
do it till it's done.
Yeah, it should have happened in 3 tries.
Mine did it.
Yours did it in 2 tries. So what should happen is, check out my next picture. I drew this other green line. It's a 3rd line of symmetry. And guess what the angle between each of these lines is?
60,
Yeah, 6 times 60 is
360.
360 all the way around. Yeah, so that's what should have happened. So I'm going to have to think about why this didn't quite work for some of us. That one looks pretty close. It could be maybe my cutting wasn't very good this time, but usually I'm a pretty darn good cutter.
Still coming. I'm getting there.
Yeah, so see if you
Write
can
it
find
down.
your 3rd line. Yeah, mine's not quite right on that 3rd line of symmetry. Okay, yeah, so something went wrong. All right, so I have some homework. I'm gonna do this again and see if I can figure out why sometimes it doesn't work out in 2 or 3 steps. The author of this activity believed it should. All right, how are we doing on time? It's 4 o'clock. All right, so we're gonna take a little break and then we'll come back with the rest of this activity. Stop this recording because it may have gotten messed up in between.